Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Hadi bin Abdul Halim. In this video, I would like to present for mini project Ece354 with my groupmate Abdul Aziz and Afrina Anissa. So our title for our mini project is addition of 32 bits with another 32 bits. The question given is build a program to add the hex number $ABCDEF12 from address, example $1600 with $4567EEFF from address, example $1605, then save the answer at starting address $1800. So our objective for the mini project is first to execute data transfer operation such as load and store. Second is to perform arithmetic operation which is addition. Next is to make sure that the end of the result is same as the theoretical calculation. And last but not least, to understand the usage of condition code register that we know as the CCR. So this is our flowchart for overall program. So this is our result for coding, which is we will explain in detail in the next slide. So first, we need to set the starting address $800, and then we reserve two address memory location for label sum and I, and then we move the data to the memory location for label sum and I. So as we can see at the simulator, at address 800 until 801, we have reserved the address for label sum, and at address 802 until 803, we reserve address for label I.
Hello, my name is Abdulaziz and I will continue from the previous part. The next line is to load the first given 30 bits data in accumulator X and Y. Then the X will be stored in the address $804 while Y will be stored in address $806. This is the data stored in the address 804 and this is the data stored in 806. Since it is the 16-bit, so the data will be divided into two addresses for X and Y. Then the next 32 bits data given will be loaded into accumulator X and Y, and it will be stored in the address $808 and address $800A respectively. This is for the X for the second data, and this is Y for the second data. For the next line is to load D with the data pointed by the address $806, which is 806 is EF, but since the D is 16 bits, so it will take EF12. Then the data D will be added with the data pointed by address $800A, which is EEFF, and it will be stored in the address $800E, which is here. This is the result from the addition of the EF12 and EEFF. Then the accumulator D will be loaded with the data pointed by the address $804, which is ABCD. Since this is the accumulator D, so AB will be in accumulator A and CD will be in accumulator B. For the addition, we must do the calculation from the right to the left, since it will involve carry in CR. So the B will be at first. The next line is to add B with the data pointed by the address $809 plus with carry, which is from the operation before. So the data, then the A will be add with the data pointed by address 808 plus with carry, and both of it will be stored in the $800C for A and $800D for B. So this is the answer for the overall operation, which is the F135DE11.
Hello, my name is Afrina Anissa binti Sharifuddin. I will continue from where my groupmate stopped. We continue with the next part of the coding. The next line of coding is LDX$80C. This instruction is to load the data from address 80C into the register X. The data of 80C is F1. Since the register is register X, it is a 16-bit data. So we will take the data of F1 and also 35 and load it into register X. So X has the value of F135. The next line of coding is LDY$80E. The concept is the same as the previous line, which is load the data from address 80E into the register Y. The data from address 80E is DE. Since Y is also a 16-bit data, so we will take the next address also, which is 80F. So the value of Y is DE11. As you can see here. The next coding is STX sum. This is to store X into the address point labeled as sum. From the previous coding, we had already loaded the register X with the value of F135. So we will store this data into the address that is labeled as sum. The address that is labeled as sum is at 800, and because X is a 16-bit, so we will store the data into address 800 and 801. So it is now F135, the same as register X. The next coding is STY. I is to store the data from register Y into address labeled as I. The address that is labeled as I is at 802. The Y is a 16-bit data, so we will also use the next address, which is 803. So the data of Y is the same as the address labeled as I, which is DE11. SWI is to interrupt the program from running, and end is to end the whole program. As for the conclusion, it can be concluded that this experiment is for the arithmetic of addition. The data used for the operation is a 32-bit data added with another 32-bit data. The first bit data is ABCDEF12 and added with data 4567EEFF. This experiment made addition easier and faster because it is able to do quick addition with a larger bit data. This mini project has been successfully done. All these objectives have been achieved. Okay, we have reached the end of the video. Thank you for watching. Bye!